So I decided to make a movie in addition to the answers that I posted regarding the quiz we did in class the other day. So the most important factor in determining variation in size is you go from left to right in a series. Now that means you're starting on the left side of the periodic table, you're going in this direction. So basically there are two factors that affect these periodic properties we've been talking about. One of them, as you go this way, it's the number of protons. Oops. All right, here we go. So as we go down, little arrow problems here. Okay, so we had two trends. So as you go this way, we're talking about protons affecting all of the trends, or all of the properties. As you go this way, we're talking about energy levels affecting the properties. So as you go left to right, it's kind of like this in terms of size. You start, if I did, let's say lithium, it would look like this. Have two energy levels. Then beryllium would be like this.
Noah Trevino, please report to the main office.
Boron would look like this.
Please report to the main office.
And then carbon.
Bella Trevino, please report to the main office.
Nitrogen.
Bella Trevino, please report to the main office.
So you get the idea that they're getting smaller as you go from left to right. And the reason for that is because the protons are pulling the outer shell in tighter. So if you want to say increasing protons, the only answer here that makes sense is A, that's the increase in nuclear charge. Because the nuclear charge, in a nucleus, you know, you got protons and neutrons. And there's no electron there, so the only nuclear charge is positive.
Please report to the main office. Morgan Trevino, please report.
Now, as you go down to family, that's going this way, so you're adding an energy level. So if this was lithium, that'd be sodium. 1, 2, 3. This would be potassium, and so on. So you're just adding an energy level over time, every time. So even though there's more protons, you have these inside electrons that are pushing out. All right, sorry, I think I erased the energy level there. So 1, 2, 3, 4. Yeah, so you have the inside electrons that are pushing the outside electrons away. So here you got inside electrons, and they push away on the outside energy level. What do we call that? We call that shielding effect. So as you go to the bottom, you're increasing inner shell electrons. That's the inside electrons. You're adding energy layers, energy levels, I mean. Okay, as you go down the oxygen family, you're going, if the atomic numbers are increasing, so increasing, then that means you're adding more energy levels as you go down, so the shielding effect is going to increase. All right, on this one, ions formed by the gain of an electron are always more blank than the atom they came from. Well, if you add that's electron affinity when you add an electron. So the energy change is called the electron affinity. And you remember that sometimes energy is released when you add an electron. Actually, mostly energy is released when you add an electron. But sometimes energy is required. So if you have an S2 or a P6, you would expect a positive value for the electron affinity. Remember that a positive value means that energy would be required to put the electron on. If the electron is added to other atoms besides S2 or P6, those guys release energy. So sometimes energy is sometimes out. So gain of electron means sometimes energy out, sometimes energy in. And it changes depending on what the atom is. So since we don't know what the atom is, the answer to that question is I can't tell because I don't know what it is. Because sometimes when you add an electron, energy is released, other times energy is required. All right, and remember, the more negative electron affinity, the more desirable it is for that atom to gain an electron. So the negative value means it's desirable to gain an electron. The negative value means energy is released. And the more energy released when you add an electron, the more desirable it is. Okay, electron affinity within a family. So we're increasing atomic number, you're going this way. So as the atom gets bigger, is it going to be more likely or less likely to want to gain an electron? So remember up here, the shielding effect says the electrons on the inside push on the outside, so it's going to be less likely to want to gain as you go down. So the electron affinity will decrease. All right, I'm going to draw a picture here. See if you recognize this picture. That is called a dot diagram, showing only the valence electrons. Nitrogen had 5. It's in the 5th column on the periodic table. How many more would it like to have in order to get to 8? So you put 1 here, 1 here, 1 here. So you're going to gain 3. And if you gain 3 electrons to get to 8, what's its oxidation state going to be? Is it going to be positive or negative when you gain electrons? Negative. All right, adding an electron to helium. Now remember, stability means if it's more stable, it's a lower energy state. If it's less stable, it's at a higher energy state. So if you're going to add an electron to helium, helium is a 1s2. So does it have a full s sublevel? Yes. So anytime you add an electron to a full s sublevel, energy is going to be required. So the ion would be less stable. All right, number 8, which is the most metallic. Most metallic would be the one that's the biggest. So you look at your size trends. Here they are roughly. You got O, you got S, you got arsenic here. Oops, take it back. That's not where arsenic is. So let's erase that. O, S. Selenium is down here. And then arsenic's over here. So which one of those is the biggest? Remember, size increases as you go down, and size increases as you go left. So arsenic will be the biggest, and it's the most metallic, even though it's not a metal. Okay, chlorine, I'm going to draw a picture here. This is the dot diagram for chlorine. It has 7 electrons in its outer shell. It has 1 open spot right here, down at the bottom there. And so right here is an open spot. So it's going to gain an electron because it's got 7, so it's going to gain 1, it becomes an ion. So if you gain an electron without changing the protons, so situation A, you got 17 pluses and 17 negatives. Situation B, you got 17 pluses and 18 negatives. This one will be bigger because the protons can't hold the electrons in as tightly. So the chlorine ion will be bigger. All right, which is least likely to gain electrons? Gaining electrons is harder for big ones and easier for small ones, unless the small one has a full outer shell. So you look at these guys, and which is the biggest? You got magnesium's way over here on the left side, then you got in the same column as magnesium, or excuse me, in the same series as magnesium, you have chlorine, and fluorine's up above it. Oxygen is over here. So which one of these is the biggest on the periodic table? Not to mention, it's a 1s2 configuration, which also says we don't add electrons. So the answer is A. High ionization energy. All right, that means it's going to be difficult to remove an electron. So would it be more difficult to remove an electron from a big atom or a small atom? Small. Remember, as you go to the right, they get smaller. So which one of these would it be most difficult, from which one of these would it be most difficult to remove an electron? It'd be this one, because it's the smallest. It's holding its electrons tighter. So that's on the non-metal side. So high ionization energy is characteristic of non-metals. And which one has an opposite pattern from atomic radius? Well, radius got smaller as you go in this direction, like that on the periodic table. But the others all got larger as you went in that direction. So they all are opposite. Okay, so if energy is released during a process, energy out, more stable. That's why things explode. You want to go to a lower energy state. Lower energy states tend to be less reactive. Okay, an atom which lost energy during an electron transfer. If you lose energy during an electron transfer, that means that energy was released. So remember, ionization energy always requires energy. So I'm going to say always energy in. Electron affinity sometimes energy, but usually energy out. Okay, so an atom which lost energy during an electron transfer must have gained an electron. Because ionization energy is removing electrons, and you always have to put energy in for that. All right. 15. Which one has a positive electron affinity? That means a energy in. Positive electron affinity means energy in. So that would require an S2 or a P6, and none of these fall into that category. Oh wait, one of them does. So which one falls into the P6? Neon does. Potassium is an S1. Be sure you understand this language. This is a P6. This is a P4. This is a P5. So the P6 has a full P sublevel, requires energy to stick. Number 16. The stability of the ion formed by the gain of an electron. So we're talking about electron affinity. Sometimes energy in, usually energy out. We don't know what the atom is. So all you can say for sure is it's sometimes less. You see, always less wouldn't be right, because that would mean you always had to put energy in when you gain an electron. The same doesn't make any sense, because anytime you have a change in nature, you have a change in energy. And always greater wouldn't be right, because energy is not always released. Always greater would mean energy is released in terms of stability. Less stable would be energy in. So best you can say is sometimes, because electron affinity can go either way. Okay, this is the largest. Remember, I think I wrote this on the board the other day. So protons, electrons. This would be 10, 10. This would be 9, 10. This would be 11, 10. This would be 12, 10. So which is the largest? It's the one that has the fewest protons. So B. All right, the bonding with oxygen in a 1:2 ratio. Here's oxygen. 6 valence electrons, going to gain 2. All right, so each oxygen atom is going to gain 2. A 1:2 ratio means you got X, O2. Each one of these O's gains 2 electrons, but there are 2 atoms, so the total gain would be 4, because there are 2 atoms, each one gains 2, according to this picture. So then this had to lose 4. But how many atoms are here? There's only one atom of element X, so that one atom had to lose 4 electrons. So you're looking for an element that has 4 electrons in its outer shell, and they are carbon, silicon, germanium, tin. Did I skip one? What did I skip? Tin, lead. That's 4. But this one says it would be isoelectronic with neon after it lost 4. So you'd pick silicon because it has 14 electrons, and when it loses 4, it becomes like neon. Also, that's the only one that's listed here with 4 in its outer shell, so it had to be silicon. Okay, number 19. Sodium's electron configuration looks like this: 1s2, 2s2, 2p6, 3s1. Notice that there's only 1 in the outer shell. So that 1 electron will be lost fairly easily, but the next electron has to come from the second energy level. So it'll be a lot more difficult to remove an electron from down here. You'd expect a big increase between the first and second. Now, suppose the element had been magnesium. Magnesium would be 1s2, 2s2, 2p6, 3s2. Those would come off easily. So you'd have 2, so you have a huge increase in the ionization energy when you tried to remove the third electron. So the number in the outer shell comes off fairly easily. You get a huge increase when you go to the next lower energy level. All right, number 20, an element that gained energy during an electron transfer. So energy was in. Go back up here. Ionization energy, we're moving an electron, always energy in. Electron affinity, sometimes energy in, but usually energy out. Go back to this question. It gained energy during an electron transfer. So if it gained energy during an electron transfer, we don't know. Because if you remove an electron, you could put energy into it, right here. If you add an electron, sometimes energy is put in, so you don't know. So all you can do is say there's sufficient information, insufficient information. All right, then this last one, you have X3P. Here's P, 1, 2, 3, 4, 5 valence electrons. So it's going to want to gain 3. So the total gain here, in this case, is going to be 3 because there's only one atom of phosphorus. If there's nothing there, there's a 1. It's an implied 1. So that means that the loss is 3 also, because the gain and the loss have to be the same. But there are 3 atoms. So each atom loses 1 electron. So then you need something with 1 electron in this outer shell. So that could be hydrogen, it could be lithium, it could be sodium, it could be potassium, it could be rubidium, it could be cesium. But in this case, it's going to be isoelectronic with neon, so the question becomes which one of these loses 1 electron and then has 10. So sodium has 11 electrons because it has 11 protons, but if you lose 1, now it's going to have 10, and that would be just like neon, so the answer was sodium. All right, so that was kind of fast. I hope that helps. I was trying to do it all in one video without getting more so long it wouldn't play. So there you have it. Good luck on the next quiz that we have on this.